Now, I'll take in another type of agent extremely quickly. By the way, if you are like, why is this going so abstract? In the first class, all that teachers do is to tell you what all will you be learning. The details will come as specific chapters. So that's my, obviously, all this thing. Now, what we're going to discuss is called as not the goal-based agent, it's called as the utility-based agents. Philosophically, what are you really doing is passing really your goal, or your goal is to become very famous in life, or your goal is to marry your girlfriend, or your goal is to instead do social work, and this is just a step. We do not commit on this one term called as goal. When we say goal, there's a single thing and you are only expected to do that. So it's a very hard term. Now, philosophically, what you do is not something that goes to the goal. What you do is a very simple philosophical thing, and that is, what makes me happy? So you do everything that makes you happy. You get a nice chocolate, you're happy. You have that, you eat it. Simple. Whatever makes you happy, you do that. So the utility-based agent, again, one line of code. All that you do is to say that I will select action that makes me happy or that maximizes utility. Of course, you've got some rules. Rules is nothing but the rules of the game. So if you want to make a player for NFS, you want to know what the rules of NFS are. The classic rule-based system definition doesn't hold over here. Okay, so of course I've got something which is utility of everything. Now if you think about it, it's a very simple system. Of course you've got sensor and your sensor understanding around over here. Now, I suppose if you are listening to this, you are actually learning AI. Does that make you happy? Why? I mean, you could watch your favorite movie, you could watch your favorite sports, you could talk to your friends, you could sleep, lazy, and all that makes you happy. This lecture doesn't make you happy, for sure. So, why are you still listening to it? Are you non-rational? So, the answer is, if you study this, you'll give the assessment. Why do you give the assessment? It doesn't make you happy. Nobody comes out of the examination hall and says, yay, I want to give examination my entire life. I'm so happy. Examination don't make anybody feel happy. Why do you still give them? You give them because initially it may pain. Initially it may be very boring. However, later when you get an amazing job offer, only because your knowledge of AI, which you learned today, that is why the pain today is unavoidable for immense happiness of tomorrow. So when I say what makes me happy, of course there is a very big caveat. So it doesn't say what makes me happy, it says what makes me happy in the long run. And that's what utility is. Utility is not what something immediately makes you happy. It eventually makes you happy. So when you get a fancy job offer and you have your graduation, please remember this lecture and tell me the pain was large, but eventually With the hefty paycheck, it makes you happy. And without that pain, you don't get that hefty paycheck. So it's unavoidable for happiness. Now, of course, there are two things that I need to do over here. This is very simple. Just select whatever makes you happy and just do that. The other issue is, how do I calculate utility? Of course, it will be calculated based on my understanding of the sensors. It will also be based on what is called as a feedback. So the feedback would be from the user. You say, hey chatbot, what's the time? And the chatbot says, I'm busy watching a big movie. You say, you terrible piece of software written by somebody like me. That was a bad answer. So you get the feedback. Sometimes the actions also tell you what the feedback is. So, you know your bump sensor trigger, that means you collided extremely bad. You know you are too close to someone because of your distance sensor, extremely very bad. You know that after 50 lines of chatting, you still do not know what does the master want. There's a feedback. So there are internal and external feedback mechanism, and that is what you use to find out the long-term gains and the long-term benefits, the long-term returns. So all that you need to do today is just keep observing what is happening. When you get that day fact paycheck, let your juniors know. Listening to AI gives you that big fat paycheck. And that's the utility of my lecture that you have calculated, which juniors will get it for free, memory sharing. So all that the agent does is to continuously take actions that makes it feel happy in the long run. At the same time, we'll discuss it later. How do I really calculate this utility? That's also what will be the last part of the AI series around over here. Now, again, to remember that when I say utility, I naturally, without saying, means expected utility. So the actions may be stochastic. Head or tail, what will come, I do not know. Given the limitations of the model, given the limitations of my limited knowledge, so where is mom? I don't know. I can only assume that because of time she's at the living room and I'll go there. It may be wrong and I may end up becoming a fool. So now let's go to the last one, and the last is what is called as a learning-based agent. Now remember that I'll present it from the point of view of classic AI. So right now you won't get lectures that you expect learning machine learning from someone great, Andrew Ng or Hinton or whatever. I'll take it from AI perspective. Eventually you might realize that both of them are virtually the same thing. This is more this is more from an AI perspective. At the end, when I will teach you machine learning, just a bit of it because it's a full-fledged course in itself. So maybe just a little bit of machine learning is what I'll touch over here. Then I'll speak more about the standard reinforcement, supervised, unsupervised. But now let's say this is what is our agent. Our agent, of course, is driven based on some sensor and it has some actuator. After understanding all that you do is that you have a rule engine and it is fed by a rule base, and based on that you take your action. So machine learning system or learning based system are just reflexive agents. You can add model to give you more information. So they're just normal reflexive agents. Classification, it's a normal reflexive agent. Image in, diagnosis out, no coronavirus, enjoy. Don't roam about everywhere, you're still prone to it. So it's just a reflexive agent. The only change that happens is that this is learnable, which means that I can add rules, I can delete rules, I can change rules, I can modify the rules, I can do anything with the rules that I want based on what I observe. So the only difference is that my rule base now will be called as learnable. It can be changed. If you are imagining neural networks, remember that I said even mathematical rules are rules. Neural network are also a rule base. It's not if-else rules, but they are still rules. If you're expecting a fuzzy logic system, then of course you know that those are actually more like if-else rules. Anything is just a set of rules. Now here it is runnable. Now, for learning, you need a learning algorithm as well. And that is what I will have around over here. So let's say that there is a learning algorithm. Now it's a part of the agent, of course. I don't come prepared with figures, so my figures go all the way. You already know that. So there's a learning algorithm, and based on that, this rule base is also called as a learning element. So that's who learns it, algorithm. What is learned, rule base. Learning algorithm learns the learning element. So there's a learning algorithm, there is a learning rule base. Now, for learning, now you need to go with an example of learning in life. So if you're learning driving, somebody aside you will say, dude, you did this. Guess what? You had to do this. You applied brake, but it had to be gradual. In assessments, I give you a solution key and look up for yourself. That is what I wrote. This was the correct answer. And based on that, you update your memory. Next time this question comes, I will write down exactly what is in the answer solution key. Of course, if the question is mended, then you generalize and you are still able to do it because you learn the appropriate thing and not noise. Similarly, the robot goes, somebody tells it, you did that, that's what you had to do. So the learning algorithm has two inputs. The first one, which is called as a critic. The critic tells it what was to be done. And of course, now I'm talking about supervised learning. In unsupervised learning, there is no critic. How that happens, I'll talk about it when I actually take machine learning, just a bit of it. It's ideally not in curriculum. And it takes your sensor inputs also as an input in order to decide what is it that it needs to actually learn. So what the learning algorithm does is it takes the inputs, it takes the current brain, it takes what was the actual answer, and it updates this learning element. So your rule base is now updated based on what the critic said. So you applied brake gradually, and the learning element critic said, very good. You say, hey, I don't need to do anything, I learned it. Next time you accelerate too much, the critic says, very bad. You say, what was the correct answer? The critic says, this was the correct answer. You learn that. So now, of course, I understand people from machine learning background, you are used to a specific program architecture. That's real life. You get the sensor readings, you do the understanding, you act based on that, and that action is implemented. And remember, it's still cyclic, where you have the environment around over here. However, every time you take an action, somebody says good, bad, good, bad. So it tells you what was the correct answer. So based on the correct answer, you update your memory, and that happens continuously. It's not like learning based agents have just a training phase and a testing phase. They learn lifelong. Now, of course, I have to give you unsupervised and reinforcement also very quickly. So sometimes what happens is that instead of a critic, you get what is a feedback. So now it will be interesting, how is critic different from a feedback, or how supervised is different from reinforcement. Critic tells you the correct answer. This question, this is the correct answer. You will learn yourself. Feedback is just, I did not give you the solution key. All I said was, I gave you 2 out of 10. So very bad, don't repeat it. You collided. Nobody told you why did you collide. All that you know is, you did something very bad. Your master uninstalled the application. You do not know what you did was correct or not. All that you did was a feedback. What was the correct answer? What is the time? The answer is, it is 11 o'clock. So your system doesn't know the correct answer. Your system doesn't know that it accelerated quickly and the solution was lowering down the acceleration. Your system doesn't know that you did not follow the shortest route. You take a long route. What was the short route? It's not given. So a critic gives the actual answer, which is exactly same as the action. In the exactly same as the domain of the action, that is supervised. However, when you just say good, bad, very bad, then that's a feedback, that is reinforcement. Reinforcement, of course, we'll talk about later, is hard because all that you did know is what you did was wrong. You don't know what was the correct answer. Like sometimes when in classes we need to scold you because of what you answer, we just say your answer is bad. What was the correct answer? We won't tell you. So it's a feedback only. Now you need to guess what's the simplest program you can write down. If-else rule for everything. For every input you try to find out an output. Critic is telling you what's exactly the output. You could just store it as a big hefty table. For every kind of input, critic tells you what's the output. Feedback just says it's good or it's bad. You do not know what to do. So next time also you'll have to try something else. You do not know what's exactly to be done. And of course, what is both in utility and critic is a term which is called as exploration, also called as problem generation. So let's take a small example. So it's a self-driving car. I'm teaching it how to drive itself autonomously. Every time the car gets out, I tell it what to do, and therefore it does correct thing always. It always does the correct thing. Outside my campus, I've trained it a million times. It's performing beautifully. However, one fine morning, unfortunately because of noise, it gets a little bit scared by 30 degrees. Is there anything in my training database that tells it in this situation what to do? No. Feedback never recorded it. Critic never told it. Car is on its own. There's no critic now. There's no feedback. And you went to a completely new situation. What to do? So sometimes in machine learning, you need to make the vehicle take bad actions to get into bad situations, and then teach it how to overcome those bad situations. If it can do that, then of course, that's a good machine learning system. So sometimes I need to take bad decisions intentionally to teach the vehicle by chance. If you get into bad situations, you know exactly what to do. So it's good to have friends that you don't give money and you stay safe, but sometimes just give it. So you know when the friend doesn't return you money back, what you need to do. Sometimes you may completely genuinely give it for a rule base, like he helped you, you're not getting your money back, you do not know what to do now, nobody taught you. So sometimes we need to really explore, and that is what I add in my exploration as well as a fact which governs what I do. So let's have it around over here. So we talked about different types of agents. We talked about different types of systems. And this was an introductory class, of course, telling you what you will need to do later and telling you what will we be studying much later upon. So each one of these will be taken up in detail. Unless you do not already know that, let me remind you that I do not speak anything more than what is given in the book. So if you hate taking notes, it's absolutely okay. There's no need to. Everything is given up in the book. The book is called as Artificial Intelligence, a Modern Approach. Later I'll shift to another book as well, but I'll not use any different book. And again, if you are searching for more content, somebody with a more handsome face than me, it's a standard book in every university. You'll get lots of video lecture series. If you are looking for PowerPoint presentations or PDF presentations, let me not advertise a proprietary tool, then you'll get hundreds of them online, and all of them exhaustively cover this book, so you won't be at any kind of a loss. So if you're looking for notes or something like that, I do encourage you to look into all those wonderful resources as well. And it's a long day, so I'll end up here. Thank you.